Hello everyone. Today I will be walking you through our hardware integration toolset Acquire. When you're signed in, you will see the main interface, which consists of all the profiles you've created. Let's go ahead and create one to show you how quick and easy it is to get started. The first thing you need to fill in is the profile name and description. Next, and most importantly, your data source of where your data is coming from. We support a wide range of standard communication protocols such as Modbus, Kepware, Opc Ua or Opc Da server, Ethernet client or TCP client, serial client or RS-232 connection, Ethernet server, log files for machines that are too old to have any digital output, and lastly, web application program interface. Let's go ahead and create the Modbus profile to show you how it works. Import type is how you want to collect this data into the system. We support direct SQL database collection, text file export, CSV export, and package the data and send away in a web API. We'll use the database for now, and I'll fill in some default name and description for the profile. After creating your profile, you will be able to view it in the main interface and edit accordingly. The first thing we need to configure is the data provider connection details. For Modbus, those will be how often the data is collected from the controller, as well as the connection type. We support both serial Modbus and TCP IP Modbus, but in this example, I'll be using TCP IP. This requires the port number and the IP address of the controller to connect to. I'm using a simulation Modbus controller that uses the default port 502. It supports both TCP IP and serial, as well as the default address range. From my profile, I can click Test Connection to ensure that I can connect to the specified controller. You can see that a default tag has been added that tries to read data from the holding register of slave ID 1 and address 1. The current read value is 0. Now I can manually overwrite the addresses values so that you can see how they are being collected by our profile. I'll randomly set different values for each of these. When I click Test Connection again, you can see that the read value has been updated to 4 because this tag is reading from the holding register at address 1. You can add and delete tag as you need depending on the number of data addresses you want to collect, and finish off with saving the configuration for the data provider. The last configuration we need to do is for how data will be collected into our system. Recall that we selected direct SQL import, so all these details are already pre-filled to reserve a table for this profile's data. Now your profile is ready to go. You can start it from the main interface, and the data from the Modbus controller will be automatically collected into our SQL server. Let me show you where the data sits and how it looks like. A default table matching the profile's name has been created to store the data. In this case, it will be the Modbus test table because Modbus test was our profile name. When I read this table, it will show that data is coming into our system live. In fact, data is coming in every 1 second as configured in our profile in the data provider section, and the value we're reading is 4. When I manually update this holding register of address 1 to value 123, you can see this new value instantly collected into the database as well. Now, I can set up a simulation mode to automatically increment the data, and this will show you how real-time production data can be streamed into our system just with a few clicks to create the profile and run this profile. You can see the data incrementing, and the data is being changed in the simulation every 4 seconds. Now all of these are being ran in the background, so you can exit out the page without affecting the profile's run. The next profile that I will walk you guys through is Opc Ua because it's a very common standard. Now let's go ahead and select Opc Ua and database import type similarly to what we did before. I'll put in some name and description, and our profile is ready for configuration. Now for the data provider for Opc Ua, we only need to provide the server URL to connect to, as well as the data port rates. In this example, I'm using the Opc Ua simulation server called Proxys, and they have an endpoint that I can use. I'll copy this value and I'll paste into my server URL and click Test Connection. You will see that we are connected to the server, but we cannot read the value of a default tag. Now, additionally, I can provide authentication as username and password if the server requires. Let's go into the server address space and take a look at the node. You will see that the format of the node ID is different from our default tag, so that's why we couldn't read the value just now. I'll copy the correct node ID and paste it into here, and now give it a random name. And when I click test connection again, you can see that with the correct node ID, we can read the value. And clicking test connection again will give you the latest value that is being randomized by the server. Now let's go and take a look at the static data. I'm choosing a static variables folder, and the node that I'm using is a double data node. This is the node ID that I'm copying. When I paste into here and try and read, you will see that the value is 0 and this value is not changing. Now let's go ahead and revert the node ID to read from as the random item node ID and save. Now, similarly to the profile that we created before, there's nothing you need to configure for the data import section, and your profile is ready to go and be run. You can run the profile again from the main interface, and you will see the status change to running. This is when all the data has been collected from the Opc Ua server and streamed into the SQL. And similarly to the previous profile, a default table has been created called Opc Ua test, matching the name of the profile to collect the data. Reading this table will show you that the data is being pulled into the system in real time. Now, you might be wondering, what can you do with all this data inside your SQL database? Well, the first thing that you can do is to visualize it, and we have a data visualization toolset called Dashboard Designer. This is a flexible end-user configurable toolset where you can design your own custom dashboard with different views and elements through a drag-and-drop concept. We support a custom SQL query so that you can provide your own analysis and your own filter and your own logic into the query. And apart from SQL Server, we also support connecting to other commercially available databases as well. Now, this dashboard is very quick to build, and you are ready to go and view it. Now, let's open up the viewer. We'll select the dashboard that we created for this, and now set the dashboard to automatically refresh every few seconds or so. Now, you can see this data is being streamed into the system in real time, and this dashboard is being updated in real time as well. So you have set up the entire flow from setting up the profile to collect the data, to actually running it, to visualizing the real-time data with just a few clicks. It's important to note that through our Opc Ua profile, we can not only connect to the Opc Ua server and read data from it, but we can also write data to these tags, and through that control and interact with the OT layer or the hardware layer as well. To demonstrate this, I will connect to a static item, which is a double static item from the Opc Ua server, so that the server doesn't change its value constantly. You can see that when I test connection, the values default to 0. I save my profile, and my data import type is due to the SQL server that I've shown before. Now, before I start my profile, I will go ahead and clear the data that we've collected previously from that random tag on the Opc Ua server. After I've cleared this, you can see that the database is now empty. I will start my profile, and I'll check to see what data we've collected so far. Because the tag that we're collecting data from is static, you can see that there's only one row being collected, as no new values are being updated to this tag. Next, I will go ahead and find out the tag ID and the profile ID that I've used to create my profile. All of these information are available inside the SQL server, where we store all these arc.quire profiles as well, and we can build a dashboard to visualize and show this to the end user. I'm using HTTP request to change the value of these tags by putting in the value, the tag ID, and the profile ID. HTTP request is very common means or communication protocol that is highly accessible with today's modern standard as well. So I will try and demonstrate the ability to write into the status tag. You can see that when I write the value 25 into this tag, the Opc Ua server returns message 200, which means it's okay. And we can see that the new data point of 25 has been collected into our system. To demonstrate how these values can be collected in real time and changed in real time, we'll go ahead and start our dashboard viewer again on the same dashboard that we have built. I've set the dashboard to automatically refresh, and I will show it side by side of how when we control and write into the tag through Through HTTP request, the values of the new tag is being updated in real time into our system. So I just go ahead and change a few values here to see it being updated in real time into the dashboard. In this manner, arc.quire has served as the middleware layer that abstracts away all the complication of connecting to the OT layer, so the end user has a more universally acceptable standard to connect and interact with the OT layer. And the same concept will apply to the Modbus as well. So we can write into a Modbus slave address in the same manner. The next data provider that I will walk you guys through is also a very commonly used data provider. It is called Ethernet client, or used interchangeably with TCP client, and it is in this case trying to connect to a TCP server. On the other end, the TCP server can be any device, from a computer to a PLC to any hardware controller. After having created my profile, I will go ahead and configure my data provider. For a TCP client, I'm trying to connect to a server, so I will need to specify the TCP server IP address. In this example, since I'm trying to connect to myself, I will use my own IP address to be the server IP address. The port number in this case is the port on which the server is listening for incoming messages from the client to know what the client wants and can respond accordingly. To demonstrate how the server and the client works, I'm using Hercules terminal, which can act as both the server and the client. On one terminal, I will be listening to port 23, and on the other terminal, I will be the client connecting to port 23 and sending data in. From the client on the right, I'm sending in this command called send information, and you can see that the server can receive it. This is where most of the server will process to see whether this is a valid read command to process it and return the correct value. In this case, I'm trying to send back a random message. In a similar manner, in this arc.quire profile, I can put in the command that I want to send down to the server. I can click test connect, in which case this will establish a connection to the server and send this command down. You can see that from the server on the terminal, we've received this command, so let's go ahead and respond with something. I will key in a random response, and you can see that the moment we receive a response back, arc.quire will establish that it has connected successfully and display the value there. Now I can save this profile, and I can go to my refresher, and this is where we define our data import type, which will be SQL in this case. Now when this is done, my profile is ready to go. What I can do is I will change this push rate to 10 seconds, so that gives me a little bit more time to respond to it from the server side. So my profile is ready to go. I will start this profile, but before that, let me drag this window over here. I will start the profile, and every 10 seconds, this profile will send the command down to this TCP server. The TCP server can take its time and respond to this command and send back something. So in this case, I will send back the value 1, and I will wait for the next command to be in. So you can see that the next command has been sent down from acquire. I will respond with the value 2, and I will wait for the next command. Very soon you will see that the next command from acquire will come down again, and the server will respond with something. So now I've responded with 1, 2, 3, 3 different values from the server. Let's go ahead and take a look at our database. Similarly to the other two profiles, a table has been created matching the profile name to store all this data. In this case, it will be the Ethernet client table. You can see that I've received 3 data from the server responding to my messages, and I've saved it here. I've shown you guys how we can act as a TCP client connecting to a TCP server. Next, I will show you guys how we can act as a TCP server awaiting messages from a client as well. In this case, I will also use the text file import type to show you how that works. Now I've gone ahead and create this profile. Next, we will go ahead and configure our provider configuration. In this case, since we are the TCP server, I want to configure the IP address of myself that I want to listen on, as well as the ports that I want to listen on. I can also configure the read timeout of the exchange, as well as any encoding method and any terminator that I expect from the client. When this is ready, I can click Test Connect, and I will start listening on this port. From the terminal over here, I will connect to the port and send this data down, and you can see that we'll receive this data and show the connection as successful. With this, our profile is ready to go. I will save this profile. My refresher is where I can define where the text file will be. In this case, we have default location on the computer. We'll save to this Ethernet server data text file. I will copy that address as well as the text file name in here, just to make sure everything is in place. And I can save this, and now my profile is ready to go. So from the main interface, I will go ahead and start this profile, at which point I will start listening onto port 23 that I'm on the network that I'm on. From this terminal, I will connect to this ports and I will start sending in multiple different data points. You can see that every time I'm sending in, the server is responding to me with what they have received. This is for me to make sure that they receive the data that I'm sending in. I will send in several data randomly and show you how these data are being recorded into the text file that we have specified. So let's send 3 data points down there, at which point we are okay to disconnect. Now, if I go into this text file, you can see that the data has been recorded with the 3 messages that I've configured, as well as the port number and the IP address that was sending in from, as well as the timestamp for that. And with that, I've shown you how we can act as a TCP server and other clients can connect to us and push data to us as well. The next thing that I want to show you guys is our last data import type, and also the most flexible. It is Web API, or the equivalent of HTTP request. For this example, I'm using back the Opc Ua profile that I've created that is reading value from a static data tag. When I start this profile, you can see the static value of 21 from this tag is being recorded into the system. Now I can construct an HTTP request that will update the value of this tag by specifying the arc.quire and the tag ID. I'm updating it to 5, and you will see that the value of the tag has been updated and collected into the system as well. What I will do next is I will create a second profile that uses the Modbus data provider and use my Web API as the data import type. I will give it some default name and description and save my profile. The provider configuration for this Modbus profile is exactly as before. I'm connecting to my Modbus simulation server, and the current value I'm reading from is the holding register at address 1. I will change this value to 1 and show you that it's being updated here. I will go ahead and save this provider configuration and go ahead and configure my data import type. In this import configuration, you can see that I can configure a custom HTTP request to send and to package and send the data that I've collected from the Modbus address away. In this case, I will just use the same URL that I'm using to write into that Opc Ua server tag, and I can put in the value of the Modbus address that I've read into the body of the message. When I click test connection, a default value of 123 will be used in place of the value placeholder. So you can see that the value of the Opc Ua tag has been changed to 123 and updated here. So I can go ahead and save this profile right now. Before I do that, the last thing you can configure is the header of a HTTP message. You can add or remove header accordingly, and all the default header options are already populated for your convenience. Now I can go ahead and save this profile after I've changed the refresh rates to 3 seconds, as well as updating the data pull rates from the Modbus controller to 3 seconds. Now go back to the main interface and start my Modbus profile as well. What's happening when I run this Modbus profile is that data is being collected from the holding register address 1 of the Modbus simulation server every 3 seconds. And as these data is being collected, it is being packaged into that Web API or that HTTP request that I've configured and sent to write that value into the Opc Ua tag. So you can see here, every time I change the value of this Modbus address, the Opc tag get updated with the same value. This is because all this value from the Modbus address is being packaged to the Web API and sent away. But you can write and you can configure any Web API call from the Modbus profile. It doesn't have to use the Opc Ua. This is just an example. The last data provider type that I will walk you guys through is actually just Web API. This is useful when we need to connect to some Web API server that is listening to incoming HTTP requests and would return with something, maybe with data, certain data that you want. So in this profile, I will just use Web API as my data provider type, and I'm using database as my data import type. In the provider configuration, this is where you can configure the HTTP request that you want to build out, so for you to connect to your server. So here I'm using the default testing Meowfax URL server, and what this server does is every time you make an HTTP request to the server, it returns to me with a random cat fact. So you can see here when I click test connection, it's returning me with a data object with a random cat fact inside. And every time I make a new connection or make a new HTTP request to the server, it returns me a different cat fact. So I would save this data provider configuration, and my import type is already by default created for me. So when I run this profile, what would happen is arc.quire is constantly making a get HTTP request to that cat fact server, and as the HTTP request get responded with random cat facts, it will save into the database. So now we can go into the data table for this profile, and we'll see that random cat facts are being randomly generated and added into the server every second here. So this shows you at a glance how you can create a profile that will connect to a web API server to read the data from there as well.